continuation of the second unit, that is projection of straight lines. So in projection of straight lines, we have a various positions. Those are, first one, a vertical line in the sense straight line. When the line is placed perpendicular to the horizontal plane and parallel to the vertical plane, then draw its projections. That is one objective. Second objective, you need to draw the projection of a line when it is placed parallel to the both planes, parallel to the horizontal and vertical planes. And third one, line inclined to HP. The line AB is inclined to horizontal plane, and next one is a parallel to vertical plane. And fourth one is line inclined to vertical plane and parallel to HP. So finally, when the line inclined to both the horizontal plane and vertical plane. So in this class, we will discuss first case, line perpendicular to both HP and parallel to VP. Here we have one more condition, sub case is there, that is perpendicular to VP and parallel to HP, vice versa. And second case, line parallel to both the HP and VP, but there is no possibility of line perpendicular to both planes. That is not possible. Third case, line inclined to one plane. So it is these two are the simple positions. And line inclined to one plane is projection of plane ones. Sorry, line ones, projection of line one. And last one is a lines two, projection of lines two, projection of line one, projection of line two. So now we will discuss one by one what is a projections, how we will draw the projection of straight line when it is placed in a first quadrant. All are in first quadrant only, that is first angle projection. We have a various orientation, so out of all 5 are important. Now we will discuss the projection of a straight line when it is placed in different orientation. Suppose the first case is a line perpendicular to HP in the sense horizontal plane and parallel to vertical plane. First of all, we just imagine the pictorial view, then we will go to the orthographic projection. So that is the first angle projection, pictorial presentation. As you know, this light sky blue color is a vertical plane and this one is a horizontal plane. So now the object here is a line. So it is a first angle projection, first quadrant, and the object is placed between the vertical plane. Here observer is placed, stands in front of the vertical plane. So then we'll get the front view. Suppose the observer is above the horizontal plane, and then we'll get the top view. So this line is the intersection of the two vertical and horizontal plane, principal planes. It is a reference line, XY. So vertical plane, horizontal plane, it's a pictorial representation. Now see, the red color is a line. So it is a AB. Now see the position or orientation of line AB is, the line is perpendicular to the horizontal plane. See the perpendicular to the horizontal plane and parallel to the vertical plane. So when the line is perpendicular to the horizontal plane and parallel to the vertical plane, then what is its front view and what is its top view? So we will see the front view position, the front view shape, whether it is a true length or a reduced length, apparent length, or it is a point. So we will see one by one. So suppose say the point AB is placed in a first angle, first quadrant, and the orientation of the line AB is perpendicular to the HP and parallel to the VP. So the arrow direction represents the projectors. So observer is in front of the vertical plane and observes the object. Object here is a line AB. Then the front portion of the line AB is projected. The shadow of the line AB is projected on vertical plane. That shadow or that projection we will call it as a front view. So that is a projection, point A projection, and B is a B point projection. So the dark line and the black dark line represents the front view of the line AB. So in similar to in projection of lines also, all the front views and top views are represented with the lowercase, If the front view is represented with the superscript and without superscript it is a top view. The front view is represented as a dash and B dash. So A dash and B dash. Similarly, top view of the line AB projected on horizontal plane, because it is vertical, so its entire line seems to be a point. So therefore, the top view of a line AB is a point. So A and B are coincide with each other. So that is a top view. Now we will draw the orthographic projection. So orthographic projection means you just turn the horizontal plane in clockwise direction with an inclination of 90 degrees. Then the vertical plane and horizontal plane both are in a line, and then only we will get the orthographic projection. See here that these two lines. So that line is the what is that line? The line AB is suppose some distance, suppose say HMM above the horizontal plane, and the horizontal distance, the distance represents the line is in front of the VP. As you know, the description in the first angle projection, what is the description if it is a point? The description is the point A is above HP and in front of the VP. In front of the VP. So if the point A is, so here we have a 2 points, the point A and point B. So point A also above HP, see the point A is above HP. So that represents the say H1, we'll call it as in, and the D1 is an in front distance. Similarly, B point also. So B point also above the HP, some distance is above HP. This distance we will call it as say H2, and in front of the VP. So in front of the VP, that is a D2. Here D1 is the in front distance. So A position and B position in terms of the above and in front distances. Here, this distance is known as a above distance. Above distance. It is a D2. And this distance is D1. Sorry, it is a H2. I'm sorry. This distance is a point B is a H2. The point B is some H2 mm above the HP, and A is H1 mm above the HP. Similarly, this distance is known as a in front distance. So this one is a D1, and here also it is also D2. If you observe carefully, if the D1 is equal to D2, so it means that the line AB is parallel to VP. So indirectly, suppose the two in front distance, the two endpoints of the line AB are same, in front distance are same, then we can directly say that the line AB is a parallel to VP. But here, the line AB is H1 is not equal to H2, so therefore H1, H2 are the above distances. Now coming to the projections.